Okay, geometry team, we are ready to finish up our midterm review starting at problem number 30 now. So here we have problem 30 on the board, and here I have triangles where I'm given a random angle, and it is not one of our special 30, 60, 90 right triangles. So I don't have two congruent sides, but I have an angle in a side, so this is where I'm going to be using trigonometry. And when we have trigonometry, we have three functions that we use. We have sine, we have cosine, and we have tangent. And to help us remember which ratios go with which of those functions, there's a little reminder that we use that's SOHCAHTOA. Okay, and I'm going to angle this up so you can see it. So SOHCAHTOA tells us which ratios go with which trig functions. So if I have opposite and hypotenuse, I'm using sine. If I have adjacent and hypotenuse, I'm using cosine. And if I have opposite and adjacent, I'm using tangent. And so, looking at this problem here, I've got just the angle 37. And I want to know which trig function I can use to help me figure out x and y. So I'm going to focus on labeling my sides so I can figure it out. So the side opposite here is always going to be my hypotenuse. My 37-degree angle, this y is opposite that, and this 11 is adjacent to the 37 degrees. So I have an opposite side, an adjacent side, and a hypotenuse. So now to find my use my 37 degrees and find x and y, what I'm going to do is I'm going to pair my x with the number I know. So I'm going to pair 11 and x. Well, that's pairing my hypotenuse with my adjacent. And when I pair my adjacent and my hypotenuse, I know to use cosine on my angle. So I'm going to use the cosine of 37. And the cosine of 37 is going to be my adjacent over my hypotenuse. So 11 over the x. So I'm going to prepare now to try and figure out what x is. Well, x is on the bottom of a fraction. Whenever I solve for x, I need it to not be in the denominator. I need it to be in the numerator, or a number in and of itself. And so, okay, to get it off of this divided by x, I'm going to times both sides by x. And this is going to give me x times the cosine of 37. And over here, those x's canceled out, and I'm left with just the number 11. Now that didn't get x by itself yet, but it got it out of the denominator of the fraction. Now to get x by itself, I see that x is times by the cosine of 37. To remove times by the cosine of 37, I need to divide by the cosine of 37. Well, if I divide on the left, got to divide on the right. And so those will cancel, and now x will be all by his little lonesome. And over here, I just have to do 11 divided by cosine of 37. This is where you type it into your calculator exactly as you said it. So 11 divided by cosine of 37, and that's going to give me 13.77. And I will tell you on the test, or Ms. Hunt, I don't know, we'll tell you how many decimal places we want, whether it's the tenths, the hundredths, or rounding to whole numbers. We will let you know what we want on the midterm. All right? Moving forward now, I need to find y. So I'm going to pair y with the side that I have. And so, okay, I've got my 37-degree angle, and to pick my trig function, I'm going to pair y with 11. Well, that's an adjacent and an opposite. And so going back to my SOHCAHTOA reminder, when I have adjacent and opposite, that's tangent. And so I'm going to tangent that 37 in order to get what I need. Well, when I tangent 37, I'm going to use its opposite and its adjacent. So the opposite is y, and the adjacent is 11. Come step out of the way here. So now I just need to figure out what y is. Well, to get rid of this divided by 11, I'm going to times by 11. But if I times it over there, I have to times it over here. So over on the left, I have 11 times the tangent of 37. Didn't need that. Those cancel, and I'm left with just y. This is now something you can type straight into your calculator, 11 times the tangent of 37, and y is going to come out to equal 8.29. And so now I have the length of x and I have the length of y. Moving on now. For problem B. So here, I have another 30, 60, 90 triangle. You are certainly welcome to use the ratios for your special rights to solve this, where you did a 30, a 60, and a 90, where you had your short root 3, and 2 times your short side. When you did that, this 11 is your hypotenuse. The 30-degree side is with x, and this is y. And you can certainly do that, okay? So that would give your short to be 5.5, or 5.5, which would be, what, 11 halves. And in this case, this be 11 root 3 over 2. Okay? But what if I ask you for the decimals? Or what if you just start getting into trig? You can still do this with trig. If you're doing that, you would look up here and say, okay, I know I have the 60-degree angle. I have my hypotenuse, and then my opposite of the angle I know is here, and the adjacent to the angle I know is right there. So let's see if we can get these numbers using that trig to make sure it works, because it's got to work every way we try it or we've done something wrong. So I'm going to go, okay, if I want to find x, I'm going to pair it with the number I know, which tells me I'm using adjacent and hypotenuse. And with adjacent and hypotenuse, that's cosine that I'm going to be using. That's what the C tells me. So I'm going to do the cosine of this 60-degree angle using my adjacent over my hypotenuse. Times both sides by 11. And x will equal whatever 11 times cosine of 60 is, which turns out to be 5.5, which is exactly what we had found over here as a decimal. 11 divided by 2 is 5.5. Now I need to find my y. And so we're going to go, okay, to find my y, if I pair it with the piece I know, that's going to be paired with my opposite and hypotenuse. Opposite and hypotenuse is sine. So I'm using the sine of 60, and my opposite is y, and my hypotenuse is 11. So again, I'm going to solve this by getting y by itself, and now I do 11 times the sine of 60, and I get 9.53 for y. Well, if I do 11 times the square root of 3 and divide it by 2, this is the number your calculator is going to produce. And so you've done it either way, gets you the same answer. If I'm asking you for radicals, that's a clue to use this setup because this tells you the actual radicals. If I ask for decimals, you can use the trigonometry to find it that way. Okay. Sometimes you just get lucky and you have lots of choices for ways to solve problems, just like when you're an adult. Sometimes when you grow up, there's lots of ways to solve problems. Okay, so for problem C here, I'm wanting to find the measure of angle ABC. That's this guy, right down here. And ooh, that's right where the glare is. I am sorry about that. Let's see, maybe if I scoot you over just a little bit. Not so glary now? Yeah, that's better. Okay, so I'm wanting to find that angle. Well, if I want that angle, I should probably use the two pieces that I have of the triangle already. So you go, okay, what pieces do I have? Wow, that's really dark. Nothing I can do about that. Just hang with me. So to do this, I'm going to say, okay, here is the opposite side of the angle I'm focused on. The angle I'm focused on, I'm going to call it x. The opposite side is over here. My adjacent side is down here with the number 4. And my hypotenuse is up here with the number 5. And so if I want to find angle x, I should use two parts that I already know. Let's use these two, my adjacent and my hypotenuse. My adjacent and my hypotenuse are going to tell me to use cosine. And so when I do cosine of my mystery angle, I know to use my adjacent and my hypotenuse. So cosine of x is 4/5. But there's the problem. I don't want the cosine of x. I just want to know x. But it is in the process of being cosigned. And so I need to undo that cosine so I can find out where x started. So to remove cosine, I'm going to use the inverse cosine. But if I inverse cosine on the right, I have to inverse cosine on the left. When I do that, the cosine and the inverse work against each other, and I have x. And over here, when you put this one in your calculator, the inverse cosine of 4/5 is going to come out to be 36.87 degrees. Okay, so remind yourself that whenever you're cosigning an angle or some kind of letter, that's a whole operation you have to inverse. It's not a multiplication here. It is a cosigning here that we have to inverse cosine. All right, clear it off. And now we get to turn the page. All right, so for part D, I need to find the measure of angle ABC in here. So it's going to be the same kind of thing. I need to locate my angle, so angle BAC is this guy right here. We'll call him X. And so once again, I know I have two sides in a right triangle, so I'm going to immediately think about my trig functions. And so, okay, here I have my hypotenuse. Here is the adjacent side to the angle I'm looking for. And here's the opposite side to the angle I'm looking for. And so I go, okay, if I have adjacent and opposite are the things I know, that's going to tell me to use the tangent function. So if I tangent my x, that gives me the opposite over the adjacent. And once again, I want to find out just x, so I need to remove the tangent. I remove the tangent by using the inverse tangent on both sides. The inverse tangents will cancel each other out, and we arrive right back at x. When you put the inverse tangent of this fraction into your calculator, you end up with 61.19 degrees. All right? Number 31, moving right along. We're going to find the lengths of all the sides in this triangle. We've got lots of things going on here. So I have two sets of triangles in here, so I'm going to focus on each one separately, depending on which one tells me the most stuff first. You start with what you know and work your way into what you don't know. So on this side, I have one of the pieces, and I have the angle. On this side, I don't have anything. So I'm going to start with what I know first. I know I have this angle that's 31 degrees. Oops, sorry, I was trying to move my answer key where I could see it. And I have this side, which is the hypotenuse of this purple triangle. So I'm just focusing on this purple guy for now. This side right here is my adjacent side. I'm going to call it X. And I'm going to call this side Y. Because if I can find this side, I can use that in this triangle and find all of these pieces. So I've got to find all these parts. Okay? So this will be my opposite, my adjacent, and my hypotenuse. Lots of work we get to do here. So to find this guy, I'm going to pair it up with a piece that I know. So that's using adjacent and hypotenuse. So that's going to tell me to use cosine. So the cosine of this 31-degree angle that I know is my adjacent side over my hypotenuse. Multiplying by 21 on both sides, x comes out to equal 18. Nope. Yeah, it does come out to be 18. I labeled it with a different letter on the thing. Let me fix those letters so it matches what you have in there. In my answer key, I did this one y and this one x. So let me switch those so it matches what you have in your answer key. There you go, Mrs. Cerna. Good job. Yay me. All right. So this side now equals 18. Okay. Now I need to find this side. So I'm going to use the piece I know with a piece I don't know. So if I'm using opposite in hypotenuse, that's going to be sine. So I will do the sine of my 31-degree angle, and that's going to involve my opposite over my hypotenuse. multiply by 21 on both sides, and x will come out to equal this stuff, which comes out of your triangle at sine of 31, comes out to be 10.82 for your x. So this guy right here is 10.82. Okay. Now I'm going to clear all this purple stuff off, and now I'm going to focus on this triangle on the right. I'm going to color him red. It's another right triangle, and I've got this 25-degree angle in there that I can focus on. So on this one, I have this 10.82 side over here that I just found, and I don't know these guys. So I'll call this one, what did I call it in my thing? I called this one C, and I think I called this one A? Yeah, I called this one A. Okay, pretending I had Pythagorean theorem here. So, okay, if I want to do this one, this is my opposite side of my angle, and oh, it was the opposite on this one too, so I don't even need to change it. This is my hypotenuse in my red triangle, and this is the side adjacent to the angle that I know. Ready to begin now. If I want to find angle A, I'm going to pair it with the side I know, so I'm going to be having my opposite and my adjacent. That tells me to use tangent when I'm using opposite and adjacent. So the tangent of the angle that I know is going to equal to the 10.82 over my mystery adjacent side. To get the A off the bottom, I will times by A on both sides and get A times the tangent of 25 equals 10.82. Then, to isolate the A over here, I will divide off the tangent of 25 from both sides. And A, come down here, A will turn out to equal whatever I get when I put this in my calculator. When I put that in, see, divided by tangent will become to 23.20 for the length of this side right here. Now to find my hypotenuse, again, I will pair the thing I don't know with a thing that I do know. And so I'm pairing my opposite and hypotenuse. When I have opposite paired with hypotenuse, that tells me I'm using the sine of my number. So when I'm doing the sine of my 25-degree angle, I'm using my opposite over my hypotenuse. Well, don't want C on the bottom, so I'm going to times by C on both sides. These guys will cancel, and I'll be left with C times the sine of 25 equals 10.82. To get C by itself, I'm going to get rid of the times junk by dividing by the stuff. These will cancel out, and C will equal whatever you get when you put that in the calculator, which comes out to be, let's see, sine. Wait, hold on. Did I just screw that up? Sine, let's see, if I'm using opposite. So, no, that is sine. I was supposed to use sine, but then I did the wrong thing on here. So now I have to grab a calculator. Hold on. Okay, now that I have a calculator, I can do 10.82 divided by the sine of 25 and get 25.60 as my C. So I have a lot of junk here. I have A and C, and then previously I had X and Y. Keeping stuff organized is going to be really important. Colors are good. Separating things out, focusing on one thing at a time is going to be really important. These get really complicated when you have more than one at the same time. Number 32. Now you get to draw pictures. Yay, we like drawing pictures. Okay. Make sure this is all, nope, it's just going to be goofy. Trying to make it a little more even for you. The technology doesn't like me. There we go. So Barry is looking at hot air balloon in the sky. Okay? So if, there, hold on. There, now I can reach it. There we go. So Barry's looking at a hot air balloon. So let's draw Barry. We got Barry. He's here on the ground. And there's a hot air balloon up in the sky. So here it is. There's a hot air balloon in the sky, and he's looking at it. If the horizontal distance, so this distance here, between Barry and the hot air balloon, so straight down from the balloon, is going to be 1423 meters. And the angle of elevation, that's the angle from level looking up, is going to be 81 degrees. How far off the ground is the hot air balloon? So that's what we're going to be trying to solve for. You go, okay, well, I have a right triangle. That's always a bonus. So since I have a right triangle, I can focus on, should I use a squared plus b squared plus c squared? Should I use one of my special rights, or should I use trig? In this case, I have a random angle, not one of my special ones, and only one of the sides. And so I think I'm going to go ahead and use trig. So this is the side opposite the fancy angle I'm looking for, or using, and this is the adjacent side. So when I have opposite and adjacent, that tells me to use the tangent function. So I'm going to use the tangent on my 81 degree angle, and it's going to tell me that I'm going to have my opposite, which is x, over my adjacent, which is 1423. Okay? To get x by itself, I will multiply by 1423 on each side, and I'm going to get x equals whatever all that is when you put it in your calculator. And when you do that, you should get 8984.5 meters. So it's really high up there, but that makes sense. We wouldn't want it to be, you know, about to hit us on the head. So moving forward, almost done. We're getting into some of the really good recent stuff now. We're on the last page. Okay, so problem 33. Oliver is standing on top of the arch in St. Louis. Y'all know what the St. Louis arch is, all right? It's a big arch, big fancy shape. It's actually got a mathematical equation for that shape, but you don't get to know that yet. And it's got the ground underneath it. And we've got somebody standing at the top of it, because you can actually go inside. There's elevators going up this arch that you can go into. So he's standing on top of it, waving to his friend over here. Hey, buddy. The arch is 630 feet tall. And remember, we always measure altitude at a right angle. So I know I'm building a right triangle here. So I've got 630 feet. And the direct distance between Oliver and John is 654. Who knows how they know it? But we just know that it's 654 feet. Okay? And we want to know what the angle of depression is. Now remember, the angle of depression is an angle looking down. So I've got him here, and if you figure this level, I know that this angle looking down from him is going to be some number. Well, that angle isn't part of my triangle. But since this level line and the ground are going to be parallel, I can say that this guy and this angle are alternate interior. So this angle is also x. So I can now use this purple triangle to find the measure of x. Awesome. I have a triangle. This side is opposite my mystery angle x, and this side is the hypotenuse of that right triangle. So when I have opposite and hypotenuse, I know that I'm using the sine of the angle I'm focused on. And so I'm using the sine of angle x, which involves the opposite over my hypotenuse. All right? And that gives me what the sine of x is, but I don't want the sine of x. I just want x. So to remove the sine from the x, I have to do the inverse operation. When I do the inverse sine here, I've got to do the inverse sine of this fraction here. These will cancel, and I'm just left with x. When I put the inverse sine of 630 over this junk over here, I end up with, my calculations tell me, 74.43 degrees. Ah! It's escaping. So there you go. That's how the angle that Oliver is looking down at John. All right? Number 34, list all the ways that two triangles can be proven and which two ways cannot be used. Remember, these are always three letters that you have to have in order to tell triangles are congruent. So I have side, 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 angle, angle, side, angle. Then you can have angle, angle, side. And then you have hypotenuse, leg, right. or sometimes just hypotenuse leg. So you got those three things there. These are the 5 you're allowed to use. The ones you're not allowed to use are angle, angle, angle. This one is a no-no. That one only tells you that triangles are similar. It's not enough information to tell you they're congruent. And the other one is side, side angle. That one, you don't want to be writing that one, because if somebody read it backward, you'd be in trouble. So we never want to use this one. Now, sometimes you're going to see side, side angle, and you're going to be like, oh, this can't be proven. But if it's side, side angle in a right triangle, that's actually hypotenuse leg. So the one time you can use side, side angle is when you can call it something else that doesn't write a funky word in your math homework, okay? So hypotenuse leg is acceptable, side, side angle is not, all right? And number 35, given, I've got triangle jam and triangle IMA. Triangle jam is this guy, J-A-M. And triangle IMA is this guy. So I've got I-M-A. And they tell me that segment JA is congruent to segment IM. So that's what I know. I want to prove that triangle MIA is, you can prove that triangle MIA is congruent to what? Well, that just means you have to find which parts correspond, okay? And so if I want these to be corresponding, I've got M and I corresponds to J and A. So that means that M corresponds to A and I corresponds to J. So M was first here. So MIA, so if I start with M here, I have to start with A here. And then if I go up to I on this one, I have to go up to J on the other triangle. And then if I slide down to my point, I have to slide down to my point there. All right? And make sure, that you label it a triangle. Okay, so the main thing here is when you're labeling triangles congruent, that you label the parts in their corresponding orders, so that if you were to line up angle M with angle A, all the other ones would line up exactly as they are listed here. Last but certainly not least, we get to do a proof just for funsies. So we've got given. I'm going to pull it down just a little bit so I have some light on my face. There we go. So we're given that these two lines, BC and AD, are parallel. That's why they're marked with these little arrows. And I'm also given that BC is congruent to AD. So now they're running the same way and they're the same length. And I need to prove that those two triangles are congruent to each other. So go, okay, let's do this thing. I'm going to start off by always listing my givens. So I have BC is parallel to AD, and I have BC is congruent to AD. Okay. Oh, well, that's already one set of things congruent in my triangles. I have a set of sides that are congruent. Awesome. Now I need to find out other stuff I can do. Excuse me. So I'm going to focus on these parallels they told me. They gave this to me for a reason. If I know they're parallel, then I know that when they're cut by a transversal, that these alternate interior angles are going to be congruent. So I can come over here and say that angle DAC is going to be congruent to angle ACB. And that's because they are alternate interior angles on parallel lines, and those will be congruent. So now I have a set of angles congruent. So now I only need one more thing to prove these triangles are congruent. Well, these two triangles share this side down the middle, right there. I'm going to double mark it because these guys were already single marked. And so I can say that AC is congruent to AC. And that tells me a third side. And this is because of the reflexive property. Anything is congruent to itself. Well, now I have a side and another side, and the angle between them being congruent. And so if I have a side and an angle and a side congruent, I can say that triangle, let's try triangle BAC, let's go BCA, is congruent to triangle DAC by side angle side. You're saying, well, hold on, wait a minute. That's not what I was told to prove. I was told to prove just that the angles were congruent. But now we can use the exciting opportunity that, oh, if I know that this triangle is congruent to this triangle, then I know that all their individual corresponding parts must also be congruent. And angle BAC, that's this guy right here, is part of the blue triangle, and angle DCA is part of the purple triangle. They're corresponding parts of congruent triangles. So if I have corresponding parts of congruent triangles, they must be congruent. That's CPCTC. So I can say that angle BAC is congruent to angle DCA according to CPCTC. Thank you so much for sitting through this walkthrough in all 3 sections. Good luck on your midterm, Highlanders, and we'll see you next year.